Ooh, hit the 15-minute max. Okay. So then the range here, we're going from, again, this implies we're going on forever kind of this way, and we're going forever kind of this way, meaning upwards and right forever and downwards and left forever. So the range here is going to go from appears negative infinity to positive infinity. And we don't have to worry about the hole in terms of range because this would potentially be a hole at 0, but 0 gets kind of covered in the range by that point. I think actually again by that point. So another way to just kind of basically say all real numbers is to say the interval from negative infinity to positive infinity. All right, domain and range on these. It looks like this domain goes from, the domain, goes from -1 to +6. This range looks like it goes from +1 to +8. But wait, there's a hole. I can't write either one of those because I got to worry about this little problem right here. So let me redo that. All right, since that hole seems to be at 3, 5, I can't include 3 in the domain, and I can't include 5 in the range. There's a 3 here that doesn't fit in the domain, and there's a 5 doesn't fit in the range. All right, and this one it looks like it does, oh, and notice I used the closed brackets at all the endpoints there, like the first and the last one, because these closed black brackets represent the black full-on points, and then the hole in the middle, of course, I got to use the round brackets. This domain looks like it's going to go from 0 up to 4, but not include 4 and not include 2, so I got to be careful of those things. And notice it does include 0, but it does not include 4. Why is that happening? Sorry, I'm trying to be fast here. And then the range does not include, because notice this is definitely a open circle down here at a range value of a y value of -2, but then it includes everything on up to 4, and it includes 4. So I noticed there is an open hole here at 4, but 4 is covered in the range because it's covered by this point. If it's covered anywhere, it counts. So I don't really even indicate. Whether or not this hole happened to be open or filled in isn't going to affect whether this is actually closed because it's closed because of this one. So yes. Wow, I hope I did all these right. YouTube changed how I used to fix things. I used to be able to do annotations. They don't do that anymore, so if I make a mistake, it's going to be ugly. All right, domain and range on these guys. No holes in this one, so it's a little bit easier. The domain kind of starts here at -9 and goes up to -10, and the range goes from -6 to 8, and there's no holes in that anywhere. This one, you gotta be a little bit careful. It looks like, okay, again, this implies that it goes on forever to the kind of northwest here, so I've got -infinity for kind of lower bound on domain, and I have upper infinity or positive infinity for a domain on, an endpoint on range. So we're gonna go from -infinity up to, okay, no hole at 2. The function exists all the way through here. There's no break in terms of what the x can be. It can be anything up to and including -2, and then from -2 onward, it picks it up down here. We're all fine. It stops at is this actually 4? No, this is 3. Sorry, I actually had to sneeze that time. That didn't work. So yeah, we go from -infinity up to 1, doesn't include 1, and again, this is 1 here. You gotta be careful of this, where the tick marks go. And then we pick up again at 1 and go to 3, and we do include 3. And then the range, it looks like it's gonna, this is actually faster. We start here at, sorry, that's not negative. It's gonna be +1. Oh, this is so tricky. It goes from 1, not including 1, on up to, we go up here. Don't have to worry about this hole because it's covered on this side. Up to 3. Okay, I keep going from 3. Keep going from 3. I keep going on to infinity. So the range actually goes from 1 to infinity, and there's actually no breaks. I put round after infinity because I always put round after infinity. All right. To convert these to domain notation, interval notation. Domain is any number between and including, so those are going to be these type of brackets. This is actually faster. -2 to 7, everything included. Whoops, that looks like a bracket. -2 to 7. Okay. Range is any number greater than but excluding 4. And again, I don't have to put x here. I'm just doing interval notation. If I was doing the greater than, less than symbols, ooh, thunder. If I was doing greater than, less than symbols, I would have to use x or y. Here, I don't really have to think about that. The interval notation doesn't indicate which one we're talking about. Any number greater than but excluding 4, so not 4, but greater than, so that's why I put 4 as that part of the thing. I'm going up from there. You could start here by thinking about this as like y is greater than 4. You could think about that first if you want to, and then rewrite it this way. Domain is all real numbers except for 3, -3. So that means we're starting at -infinity. We're doing all real numbers up to -3. This is how we do, if you remember, -3 is not included, so we kind of skip over it by not including it in the intervals that go on either side of it. And any real number, we've done this already, it goes from -infinity to positive infinity, round brackets. All right. The notation is something you've probably seen before here with the f of x kind of thing. Notation f of x is simply another way for representing the y values of f of x. So whenever they say f of x, it's like saying y equals. So if y equals 3x minus 5, what's f of 4? Or what is y if you put 4 in as x for this? So this shouldn't be too bad. Okay, so f of 4 equals 3 times 4. So 4 is now, they're just saying use 4 as the x, which is 12 minus 5, which is 7. That also tells you that the point 4, 7 should go in the graph. 4, 7, and this is not an interval now, this is an actual point, where this is the x and this is the y. And yes, I know that's confusing. It's very confusing, which is why you need to know the context of what you're reading or writing about. This is not an interval notation, this is a coordinate. 4, 7 works for this relation, for this function, sorry. Given the graph of this thing, what is, or you could also do this by graph without a function, you could be given, or yeah, without giving a rule, kind of, you could be given this this graph. What is g of -2? Well, if I put -2 into this g machine, it spits out what's the y associated with that. Remember, because we're looking for the y here. Y with that would be 1. If x is -2, this little graph exists at this point where the y is 1. If we put 4 into the function, this graph is telling me that the level or the y at that x value would be -1. Okay, in order to fully analyze a function, we got to think about all these other things. When is it increasing? When is it decreasing? And we've already done domain and range. When is it constant? This is a good picture illustrating what these three things mean. Decreasing is when it's, and again, we're talking about going from left to right. So I don't know if this is sort of fair or not. Am I still recording? What happened to my? So this, you have to just realize they're talking about going from left to right along here. So as we start here and we're moving this way, the value of y is decreasing. And then at this point, the value of y becomes constant in this kind of interval. And after we pass this point, now the value of y is going up. So it's always a kind of left to right kind of world when we go through this. It's like, well, this could be uphill if we're going this way. No, it's downhill as we go from left to right. As the x numbers are increasing, what's happening to y is what they're asking. So that's what's going on. The thing that you have to work, the thing that's going to be kind of interesting, or kind of maybe surprising about this, is when do we talk about maximum and minimum? Maximum and minimum function refer to the hills and valleys of the graph. The absolute highest point on the graph, if it exists, sometimes it doesn't, because it could go up to infinity, is called the absolute maximum, and the lowest point on the whole thing is called the absolute minimum. But if there's turnaround points, if there's a graph that does something like this, a relative maximum might be a point like this, and a relative minimum might be something like this, where all the points around it are, higher or lower, and it's kind of like a little neighborhood extreme. We're going to talk about those a lot. Okay, so state the domain, state the range. I'll do those. Okay, trying to save time. I don't think there's anything to worry about in those. State the X-Intercepts. Okay, we haven't done this yet. X-Intercepts, of course, are places where the graph crosses the x-axis. And it seems like there's an X-Intercept here, here, and here. So when it says state the X-Intercepts, now this might be something that other teachers might argue about, but I think since it's already kind of given in context that we are talking about X-Intercepts, I don't need these as coordinates. Some people are going to probably make you write -5, 0, -3, 0, and 6, 0. But I think by asking X-Intercept and asking Y-Intercept, of course this is 0, -2, which is opposite of what those were. I'll take these until I hear differently from the Algebra 2 PLC, which may happen, so just be ready. State the intervals for fx is increasing. Okay, it is increasing from when we start, from the beginning of this function before we see it. We can assume that this goes on forever, either if it goes to the edge of the graph or they actually put it now. It increases till we get to -4. At -4, here's our first kind of controversial thing. What's going on? Is it increasing at -4? Like, should I include this? Is this a square bracket? Well, the ruling here on this is no, we don't include at the point -4, it's actually neither increasing or decreasing. It can't really be increasing or decreasing at a point. Increasing and decreasing, it kind of implies we're talking about interval-ish kind of behavior, so at -4 is not really a place where it does either thing. It's also going to, okay, so then after that it decreases, so let's just go on down here. At -4 it starts decreasing, and we don't count -4. That's how we get around that, see? And it decreases until we get to 3, and at 3, of course it's not doing either thing. The next place where it starts increasing then is at 3. At 3 it starts increasing and increases all the way up to 7. Now notice I'm giving these in terms of x. Oh, and I've also seen instead of a comma here, a union symbol. I would take that either way. If you did a comma, because it says intervals. If I do it this way, it seems like I'm doing one great big interval. Here there's only one interval. It's just decreasing from -4 to 3, from -4 to 3. And again, we're talking about the x values from -4 to 3. The y is decreasing. That's what that means when they ask that. Find the coordinates of any relative maxima or minima. It appears that there is a relative maxima at -4. Now coordinates, I have no idea. I think I'm supposed to just estimate this. It's like really small, above 0. It's something like that. I might say approximately. I don't know, it makes me feel better. And is there a minima, relative minima? There's a relative minima down here where it turns around kind of this way. It looks like it's at 3, -4, but it might be a little bit farther than that. If it's this kind of thing and you don't know for sure, I will definitely take estimations on that. If you thought that was a little bit bigger than 3, like pi -4, I would totally take that. And again, these are intervals, these are coordinates. They rewrite them exactly the same way. Not my fault, I'm not going to apologize for that, but that's really, yes, what that looks like. And absolute minima or maxima, there's an absolute maximum, by the way, maxima is plural. There's an absolute maximum here. It doesn't get any higher than that. We're not going to call that a relative maximum because it doesn't turn around. We'll call it absolute because there's nothing bigger than that in this function in terms of y value. So 7,4 is an absolute maximum. There is no absolute minimum of this function. This is a relative minimum, but it eventually does get lower than that over here when we follow it this way. So we never find out where the complete minimum value is because it's -infinity and that's not a value. Okay, sorry this is so small, but I wanted to get all this stuff about the same graph on the same page. All right, is this a function of relation? So that's the one where we're going to apply the vertical line test. It is a relation because everything is a relation, basically, in this chapter. Anything that has x's and y's associated, yes. Is it a function? Yes. It is also a function because it passes a vertical line test. So it's actually both those things. I wish they didn't ask it this way and say, is this relation a function or not? Would have maybe been a better question. But this is actually both. And I'd say, how do we know? I'll answer over here because I kind of already answered with the circles. And we'll say passes vertical line test. Okay, so for one-to-one, we have to look at the horizontal line test. I'm trying to grab this little line. Okay, so does this horizontal line ever cross it more than once? And it actually does. So there's some values in here where it's crossing more than once. Like, is that actually the axis? Yeah, so it's 0. There's several x values that go with that. So this is not actually one-to-one. Sorry, so I put the how do you know kind of in there at the same thing. If you wanted to also say this on the test, like why does it fail, you could say, well, because the points 0,4 and 0,8 are both on there. So there's two y's that go with the same x. So that's not cool for one-to-one. All right, domain and range, let me do those. Looks like this actually goes to infinity. So there's some holes and some gaps and things, but it usually picks up after itself. But yeah, -2 is not part of the range. -3 is not part of the domain. But then all the other things seem to be covered. The X-Intercepts, I made the axes a little easier to see there. -1 is a X-Intercept, and 4, and 8, and the Y-Intercept seems to be at 1. Notice this is always, this could be potentially plural, but this one's always singular. It's because if the thing is a function, there should only be one of these. There can be multiples of these. Think about that. This could happen, but it couldn't be there. Well, here's what they tell you about the business with the point. When we're talking about increasing and decreasing, we always have to use the round brackets when we're doing those kind of things for increase. Well, round bracket at whichever endpoint we know we have the whole, we have the turnaround. All right, interval where it's increasing, it's increasing. Now it's not increasing here at all. It's constant here. So actually, when I see these questions, the increasing, decreasing, constant, I kind of try to do these all at once and go from -infinity up to +infinity and just kind of go in order. So it starts out as constant from -infinity. And it's constant up until -4. And then at -4, we skip to then being increasing. So at -4 it starts doing this. It's increasing until we get to -3, and then it stops being increasing. Let me fill this out off camera. Okay, and again, I'm putting commas in between stuff. I think that's okay. Am I getting my infinity in there? Yeah, so it's increasing decreasing in lots of those places. Yeah. -3 to 2, just checking, and then yeah, the only place it's decreasing from 2 to 7, it has a little hiccup here, it has a little bump here, but it's still decreasing. So I don't